Welcome, all of you, to the OpenSUSE conference. I'll be giving you a presentation about what we've done for the past 1.5 years at 040 Lab in Eindhoven, where we managed to link building information to web systems. In a brief, the table of contents. It's about building information models. So nowadays, these giant buildings, they are drew up by the architect and the constructors, etc. And they have a 3D model enriched with loads and loads of metadata. And this metadata is very important for the development of the building, but also, where we see, for maintaining the building. I'll be talking about lifecycle, industry foundation class, how these objects are specified, the method that we use in order to utilize this information in the CMS, and the results, and of course, future development. So what is BIM? A BIM is a building information model. It's a digital representation of a certain scope, in a certain context, of a building existing now and in the future. Some say that it is a process, some say that it is a philosophy, you have to think BIM. Some say that it's all about collaboration, and others say that it's just data. The last ones who say that it's all about data, those are the smart ones. But all of these people, they agree it's all about software. So why do you need BIM? In the same process as we've had in software development, the architect, the contractor, he has an idea. He throws it over the fence, and the architect, he catches it, he draws it up, throws it over the fence, and the engineer sees it, oh, we have to make some changes, then he throws it over the fence again, and then the contractor will draw new plans and throw it over the fence, and then the builder will actually build it. And we've seen this in software engineering as well, that in the previous years, decennia, it was a waterfall structure where first the design came along, etc., etc., etc. This is not so efficient. Since if you look at this curve, then you see that the more you can adapt with your design and your processes to new requirements or to changing circumstances, the more efficient you are. So normally the building industry is somewhat slower than, for example, the computer industry, and they're now adapting this. So that's why we need a building information model. And then some other smart people came along and they said, why should this building information model be something that is utilized by the big software vendors? That shouldn't be the case. It should be open. So the Building Smart Association, they got all the vendors together and they made up the Open BIM standard. So why you need Open BIM? It's an open standard for exchanging information. Objects are hierarchically enriched with metadata. All files are universally readable, which is in open source we know that everything is readable. But if you look at CAD applications and 3D building applications, then all the exchange formats are closed in format. And you don't have a vendor lock-in, but that's something I don't have to explain here. Looking at that, we want to incorporate the whole cycle that a building goes through, the whole life cycle. Initially, we'll focus on the operational and management part, while all these buildings are drew up in 3D models, and before they were on the architect's Z drive, where they rested for the rest of their life. However, the contractor, the owner of the building, he paid for it. So why not use it for operation and management? After that, we're going to start up with the design and planning, since that's easier to facilitate. We're still looking for parties to partner up with in order to make the actual building process mappable. And if you do that, if you have the life cycle of the building, then you actually know at the end, when it's going to be torn apart, what the rest values are of all the elements in the building. So one of the main goals that we have is to democratize this building information model. So not only people who are experts in building engineering or CAD, computer-aided drawing, can use it, but also people who own a building, people behind the service desks, etc. They can interact with the model of the building and therefore even interact with the building. So we want to make it very accessible. And therefore we introduced a BMS, which is actually, you have a CMS where you manage content, and we threw away the C and put in the B for the building. And then we have a BMS, building management system. Since I'm a Drupal entrepreneur from 2010, I deliberately chose Drupal for its one of the most flexible and extendable open source content management systems. Which means if we have a link between all this metadata in the building, then we can easily extend that with all the power that comes with the Drupal CMS. For example, issue tracking, discussions, calendars, calculations, workflows, etc., etc., etc. Once you have these linked data, then you can enrich these models and make them more complex. The initial project will be to have a five-year life cycle planning. That's what most owners want. They want to know for the coming 50 years or 30 years that the building exists, how can I make it as profitable as possible? So, of course, we go for the low-hanging fruit first. However, you can also think about energy efficiency, cost management, life safety and risk management. And together with a friend of us, we want also, after taking track of the whole cost and life cycle throughout the life of the building, we want to reuse all these materials. For example, it's a wall made out of keys of a keyboard. So you have rest material and you can reuse that in design, but also in new buildings. And what we're going to do is make a map, first of the Netherlands, but later on Germany, etc., where you can find this rest material and subscribe to reuse it for your project. The next step, if you have a building model and a building information service and a BMS to manage this data, then you can take this data out of it and put it in a big data cloud and then project it back onto the city, which is very interesting for municipalities, but also for people who, what's called the who have more than 2 complexes. And I investigated some techniques, for example the OpenSUSE cesium and some other 3D city generating tools in order to see which ones are the most suitable to do that. And recently I found VisiCities, which is a UK project where they take OpenStreetMap vector data and then utilize the height factor to that. And to my liking, that's one of the biggest challenges to take this. Sorry? No, they take the flat OpenStreetMap curves and then you just give it a height mapping to that. And the next step will be to use the Dutch AHN height point cloud data and then take little slices like a pancake and then you have 3D cities. That's awesome. So the industry foundation class, that's the readable, human readable standard which says that this element is a wall or a slab or a flooring, and it's either load bearing or not, it's internal, external, and it has special elements and it has material. These are the minimum characteristics. However, the engineers and the other people involved in making designs can add new metadata to that. And we utilize this ISO standard in order to get all the metadata out and get our stuff working. As a backend, we use a BIM server, which is developed by TNO, and it's an open source platform made in Java, and it's a pretty good, robust system. However, it shouldn't be hung on a public network, so we had to build in proxying inside the CMS in order to have it all secure. Furthermore, there is, just like SQL, there is a BIMQL that you can query the buildings. For example, give me all the windows on the 3rd floor that are faced east, since the ones north usually don't deteriorate as hard as the ones in east and in west, and south, of course. Then there is a collision format, it's another open standard, which is XML, and which has, at that point in the team, when you talk about a certain object, and you have an object, you have a camera point on that, and I can easily link that to a default issue queue. So what we did, we took this BIM server, we took Drupal, and we just hooked them together. We utilized Backbone, MVC, and jQuery to do that. And the easiest way, and for me the most effective way, is to have a one-to-many relation. So for one or more building elements, we create one Drupal page. And with that we can utilize the logic and other planning, etc., etc. And the first scope is to do the multi-year maintenance planning and cost flow, which works in Holland according to the NEN 2767, which just says I'm an inverted radioactivity curve. So each half time, then the level of the quality goes one step down. With an atomic explosion, each half time it halves. For each unit time, the radioactivity goes to half, but this one is just inverted. And with that, the owner of the building can say, okay, this is a factor which is really important to me. Of course, health and safety are usually on top of the line and have a priority of 1 or 2. However, it's for some owners could not be that important, or for some it should be really important to have an aesthetic part of it. For example, if you have an entrance and you get clients in your building, then it's really important to you. And with that, we can, using this law method, we can just provide the maintenance planning. Oh, sorry. So, in the end, we have a linked web with the metadata from the building, the stuff that people put in the CMS, and we can use little blocks which are available in Drupal and expose that as a semantic web through RDFx and SPARQL queries, etc. I don't think I have to explain how and what a model view controller is, so we just used Backbone to do that, for we got experience on that one. And after, now it's 1.5 years, but of hard work, we have some nice results. And I hope that after summer that we can do this complete maintenance planning. So I'm going to show you a little demo. This is the BMS. It's pretty straightforward. And let's take a simple house. So you load in a simple house, and then you can click on elements of the building and drill down through the object space. And then if you take something like wall, then we can get the properties out of there. And from there on, fetch the, I first have to select something, of course. This is a slightly older demo. What we now do is we just shoot a service at the BMS, at the building server, and get all the objects, all the IDs, and all the metadata, and then shuffle all the cards out. It takes slightly more time at the start of the process, but in the end it's far more flexible. So here the ideas of the objects come above the water, and then you can finalize the links. After that, it's easy to implement simple charting and graphics and dashboards, etc., etc. All the stuff that the management people want. So then, what we're going to do afterwards. So now we are about here. And the next step would be to actually link the model, the digital model of the building, which is enriched with this metadata, with the real building. So if we add simple sensors and actors inside the building, we can get some real-time thing in between, something like Node.js, since one of the downsides of a PHP-based CMS like we use with Drupal is that it's not really good in real-time processing of data. So something has to go in between. However, then you can just see at the end of the room that you're going to book, okay, this one was booked, but the person who was going to book it didn't show up for this time, so you can just go in and check that it's now your room. So it leads to more dynamic usage of the building itself and a better overview of what is happening with this building in relation to its usage. In the short term, we want to do facility management. project information modeling, asset management, which is also very important. What is where and where do you need it? And if you have, like I said before, if you have multiple complexes throughout the region, you can project on a map how many resources or services are needed somewhere. Then you get things like you see in a modern SimCity, where you have these little data pylons and you can find your optimum result. In the longer term, like I said, we want sensors and actors to be implemented in the building, so actually there is a one-to-one relation. When we saw the circle, the one where the building is actually built, is a hard part to get a good data and workflow on, since the contractors and the builders, they use their own planning software, which is not open, and we didn't find yet someone who is willing to work together as a pilot in order to facilitate that as well. And of course, big data. Another recent event in the building industry is that there came along a new standard. Yay! We already had a few, but the CBNL, which is a Dutch government-funded institute, they're going to make a semantic model of all building, infrastructure, and city engineering terminology. And then I thought, that's interesting, since there is a lot of communication flaws between all these parties in what you call a road, or what you call a sidewalk, or whatever is the purpose and the meaning of the object at hand. So we decided to link up with them, so push whatever we have back and gather their ontology. So we don't. This could only work if many parties join in and all work together. And I think it's a good initiative. When we go back to these little sensors and elements which are inside the building, then we have to consider the 9 principles of mundane computing. They're first expressed by Tom Coates in Webstock 2011. And that implies that a appliance should not be connected to the network in order to function. So it should be able to be unplugged. The network should be used as a progressive enhancement. It must be really, really simple to get this device working. You should do network to amplify a tool's core purpose, but not another web browser or Twitter client. The most important way to enhance an object is to make easier to control, or to understand how it's working. And the enhanced interface for a network enabled device should be whether you need it to be. And you should be able, you should be sensitive to the impact of the product's upgrade cycle, and the enhanced intelligence of the device should be in the cloud network and not in the device. And the object should communicate with its users in ways that feels appropriate and polite and permanent. And last but not least, it should be possible for the enhanced object to respond to the actions of other objects and other forms of online data. For that, there is a nice MQTT protocol, which is smaller than HTTP. I'm not sure if you're familiar with it. The big challenge for us is to implement that within the Drupal CMS. But yeah, I think there is some better options to have a broker in between, and just like Node.js for real-time stuff, it could connect as a hub. This is how such a package looks like. It's pretty straightforward. So what we did and what we bumped against is that it's pretty hard to capture expert logic in a digital system. One has to sit beside the expert and then look how this person is doing their job. Usually it's just Excel, but sometimes it's more complex. And then how and what they do, that's something which is, yeah, you could say universal IT problem, to make this flexible and to incorporate that. And for the rest, we want to add these sensors, like I said before, and have a big data projection. All that we do will be provided as GPL3 back to the Drupal and open source community, of course. I find a nice tool to do BPM, business process modeling, business process management, and that is, oops, that's one too fast, that's BONITA. And BONITA is a Java app, and it works with these management blocks, and each management block can have its functionality. So you can link it up to a online source, or it can process data from certain platforms to other platforms. And I think that these kinds of tools are the way to go in order to connect expert logic, services, and CMSs and other systems. The nice thing about it is that the whole center of it, the community part, is the full functionality, and for the corporate landscape they build all kinds of services around it. So why do we need this kind of systems? With Drupal I can easily make linear logic, go for M to B, combine stuff. However, if there is if it's non-linear, yeah, then we have to find another solution. And another important thing is that you don't need programming in order to make these schemes. And you can use it as a hot pluggable, that you have a situation with data and not one of these systems but two, and then see with different parameters and then see its results. The same with that with the translating building logic to IT logic. Since we put all the meta stuff to our own entities, somebody with the knowledge of a site builder and the knowledge of the building engineering background can create this logic. So we want to make it as democratic and as accessible as possible. This was my talk. Thank you very much. Are there any questions? No questions? Can I ask a few? Sorry. This is very much. So the question was due to that we have a information process approach and linked data approach, which one has the focus in the current project. And at this time, it is mainly to do an information-based approach to facilitate the owner of the building in its long-term life cycle planning. From there on, it will be keeping to be for facility management all those kind of processes. And once this data grows, then the information part will be very, very important. However, what in the process, we talked a lot with cost calculators, constructors, and other builders, and each of them, they had their own insights, and they want to use this, and they're very enthusiastic. However, then we came to that it's really hard to facilitate that one. So that's why the little tail came along, which at first hand doesn't appear to have anything to do with the rest of it. But in the end, if you want to combine this all and make it a bigger whole, then you need this kind of systems. And I looked around a lot to replace. I always want to have one or two alternatives to a block. But at this time, it's not really possible to exchange business logic systems with something non-Java. And the same goes for a CMS with huge possibilities that is not based on PHP. Does this answer the question? Sort of? Yes. The cool thing is that each self-respecting CAT package can export industry foundation class text files. And that's also one of the main assets of the people from Building Smart, that they involved all these CAT manufacturers to work together in order to make a good standard. So, in the end, it can be an intermediate format. For example, if you have one, I should always name two, else it's commercial. If you have Autodesk and you have Archie, then through this IFC object you can exchange the whole building. Any other questions? Thank you very much.
Hey. Hey.